Okay. So last class we were discussing about the benzoxazole, isn't it? More particularly, we discussed about the preparations. So it is possible to prepare benzoxazole starting with aminophenol, and one more reactant is acid chloride. Otherwise, one can also take orthoformate, and the products are benzoxazole. So this is this is the method of preparation or manufacturing method or production method. Okay, so with this, I will go to the next slide. I will go to the next slide. So next slide is about the chemical properties. So here you can observe that nucleophilic substitution reactions. This is a living group. Chlorine is a living group, and this will be the nucleophile. So the lone pair present on the nitrogen can attack this carbon, and the Cl will go out. So, and what is the role of triethylamine? So here there is a formation of hydrogen chloride as a byproduct. That hydrogen chloride is trapped by triethylamine. So that means the role of triethylamine in this reaction is to trap a byproduct. The byproduct is hydrogen chloride. If not, what will happen? So this HCl can come over here and will sit and can form a product itself you may end up with as a hydrochloride. So if you are using triethylamine, so it will trap the byproduct called HCl and convert into a quaternary salt. And you may, I think you may found the use of piperazine. The piperazine is present in many APIs. API means active pharmaceutical ingredients. Why active pharmaceutical ingredients means is nothing but a one of the key product used in medicine. And so more particularly, if you are looking, it is also present in antihypertensive drugs. Antihypertensive drugs means BP controlling drugs. It's also present in gastric, what you call gastric to reduce the gastric. Okay, so anti-gastric drugs also. It is, for example, pantoprazole. Okay, pan 20, pan 40. So all these things, this will be the one of the this analogs will be used as a gastric drugs. So then, if we are looking into the one more here, this also a nucleophilic substitution reaction. So here, what will happen? A nucleophile. Okay, isopropyl is a isopropylamine is a nucleophile. So what will happen? A substituent present at the second position of the benzoxazole is replaced. So that means it's nothing but a nucleophilic substitution only. But what we can say that this is a phenoxy. Otherwise, aryl oxy. Aryl phenyl is a aryl group. Aryl oxy can be replaced with nucleophiles such as amines. So here the leaving group is phenol and the product is this one. Okay, 2-amino, otherwise 2-amino isopropyl benzoxazole is the product. So with this, I will go to the one more benzofused compound. So that is okay. I will go to the next slide. I will go to next slide. Okay, it will come now. Okay, so this is the benzothiazole. What is benzothiazole? So thiazole. What is thiazole? A 5-membered ring with sulfur and nitrogen at 1 and 3 position is called thiazole. So suppose in a 5-membered ring, if the sulfur and nitrogen are at 1 and 2 position is called isothiazole. So thiazole means a 5-membered ring containing sulfur and nitrogen at 1 and 3 position is called thiazole. Suppose a thiazole is fused with benzene, then it's called benzothiazole, benzthiazole. So then if you are looking at the synthesis part, it is possible to synthesize a benzothiazole starting with amino mercaptol. So more particularly phenol mercaptol. So phenol mercaptol. Mercaptol means CH3SH containing one, but since there is a phenol mercaptol, this is mercaptol means HH group containing one. So when this is treated with formic acid means HCOOH. We can also write like this, HCOOH. So you know that the lone pair present on the nitrogen can attack this carbon. Why it is attacking? This is electron deficient. Why it is electron deficient? Because the bonded pair present over here, it will move on the oxygen. Why it is moving? Because oxygen is a electronegative in nature. If the element is electronegative in nature, it will always try to occupy anion position. So that is the reason this bonded pair move. When this bonded pair is moving, the lone pair or the bond pair attack this carbon. When this bond pair is, when there is a new bond formation between the nitrogen and carbon, this OH will go out. OH has a anion. This OH can pick up the proton from here and going out as a water. And the form of obtained compound is, this is the N position, and this group is called formyl. N-formyl. N-formyl amino phenol mercaptal. So this on heating, okay, just by heating, what will happen? There will be a new bond formation between the sulfur and the carbon. Similarly, there will be a new double bond formation between the nitrogen and carbon. So there will be a removal of water, dehydration. So the obtained one is called benzothiazole. So with this, I will go to the next slide. So next slide is about one more method of preparation of benzothiazole. This is benzothiazole. How one can prepare? So this is the starting material. So of course, phenol mercaptal is the one of the starting material. So what will happen? The SH. Okay, now SH is also a nucleophile. So the lone pair or the bond pair can attack this carbon. Why it is attacking this carbon? Because this is electron deficient. So then what will happen? OET, ethoxy, along with this proton going out as a ethanol. So in addition to once there is a formation of thioamide, this is sulfur, CO is called thioester. So then this thioester again react with this amine. So this H2 and O will go out as a water. So there will be a new bond formation between this nitrogen and this carbon, double bond formation. So that is how the product is obtained. Here R may be this complete group. Okay. So then the obtained one is benzothiazole. So it is also prepare a more convenient method. Okay. So just by taking aminothiol and treated with sodium thiocyanate. This is not the cyanide. This is cyanate. Cyanate means CYANATE, cyanate. Okay. So sodium, if we are looking into the structure, so what K plus S minus C triple bond N. So in this, carbon is electron deficient. Why carbon is electron deficient? Because you can see that this is one electronegative nature. This is also a electronegative in nature. So that is the reason always this will occupy a negative charge. When this is occupies a negative charge, this also occupies a negative charge. This become electron deficient. Then nucleophile can attack here. When what you call a lone pair or the bond pair is attacking, so then what will happen? So this can fix up a proton. So slowly C triple bond N is gets converted into amine. And also in addition to that, there will be a bond formation between this nitrogen and this carbon, and this will go out just like just like this is nothing but a OH. K means K plus S minus can picks up a proton and go out as a KSH. Okay, something like KOH. KOH is a potassium hydroxide, and here KSH. Okay, potassium thiol. This is so. This is how benzothiazole is obtained. Then after obtained benzothiazole, amino 1 at the second position, so subjected to diazotization. What is diazotization? Diazotization is the process by converting a primary amine into ammonium chloride. So how it is possible? It is possible just by treating with the sodium nitrite. Okay, NaNO2. So here nitrate means NiTrite. So there is one more thing, that is NaNO3. NO3 is the nitrate. That one should not use nitrate for the diazotization. One should use nitrite NaNO2 for the diazotization in presence of HCl. So there will be a conversion of a primary amine into N2Cl. Once the N2Cl is called diazonium chloride. So once the diazonium chloride is obtained, that is treated with ethanol. So ethanol or boric acid, any one you can treat with ethanol or boric acid. So ethanol or boric acid will act as a source of proton. So then N2Cl will go out. In that place, proton will be added. So this is how a benzothiazole is obtained, starting with aminophenol mercaptol. When it is treated with potassium thiocyanate, it leads to the formation of amino substituted benzothiazole. So this on diazotization and treating with boric acid or ethanol gives benzothiazole. So these are the methods of preparation of benzothiazole. So with this, I will go to the reactions, more particularly chemical reactions. So before explaining about this factor, I will just go for this one. You just look into this. So this is the benzothiazole. So this benzothiazole, when it is treated with N-butyl lithium. N-butyl lithium is a base. I think the proton present at the second position. So this position abstracts. So removal of the leaving group here is N-butane, and the lithium will sit on this carbon, forms as a anion. So that's what I have written here. So this anion react with the trimethyl silyl chloride. So trimethyl silyl chloride is the what is called as silylating agent. So it will silylate this carbon. The obtained one is this one. So silylated one. This can be converted into phosphorus one when it is treated with the PCl3. PCl3 means phosphorus trichloride. The obtained one is this moiety. So it is also possible to, this is a name reaction. What will happen when you are treating with TMS? TMS means trimethyl silyl cyanide. Trimethyl silyl cyanide. What will happen? So there will be a new bond formation between this carbon and cyanide. So similarly, this bond pair attacks this carbonyl electron deficient carbonyl carbon. Cl will go out. So name of this compound is called para-tolyl tosyl group, PTSCl. Okay, para-toluene sulfonic acid means PTSA, and this is tosyl chloride. Okay, tosyl means toluene sulfonyl chloride. Okay. So this is, and now let's go back to the slide. So nucleophilic electrophilic substitution at this carbon in a 5-membered ring is difficult. So that is the reason that can be achieved by converting into a silylating agent. So this is after the introduction of silylating agent. So we can go for a acylation. So what will happen? This bond, okay, this bond is reacting with this carbon, and trimethyl silyl chloride, it will form a bond with chlorine. So that is the reason. So two molecules of this one react with oxalyl chloride. Name of this compound is called oxalyl chloride. It's also a chlorinate. Of course, this can be used as a acylating agent. Sometimes this will be used as a chlorinating agent. So in this reaction, it is used as a acylating agent. So two molecule of this react with one molecule of oxalyl chloride, forming a benzyl. So this alpha diketone, okay, this is a ketone, alpha position also ketone is there. So that is the reason it's called alpha diketone products is obtained. So these are the two reactions of benzothiazole. So with this, I think we completed the benzo-fused one. So we discussed about the benzofuran, we discussed about the benzothiazine, we discussed about the benzimidazole, we discussed about the benzoxazole, we discussed about the benzothiazole. So these are the benzo-fused analogs. So more particularly, we discussed about the preparation and chemical reactions. Now let's look into the six-membered heterocycles. So these are six-membered one, and more particularly, let us look into the diazine. So di means two, aza means two nitrogen containing INE. INE stands for six-membered ring. So here these are the six-membered ring, two nitrogen containing ones. Compounds are called, in general, it's called diazine. Diazines are the IUPAC name for the six-membered compound containing two nitrogen. The two nitrogen may be at the 1,2 position, or maybe at the 1,3 position, or maybe at the 1,4 position. Only these three are possible. Okay. So suppose in a six-membered ring, if the two nitrogen are at 1,2 position, is called pyridazine. Okay. So you need to remember in a six-membered ring, if the two nitrogens are at 1,2 position, is called pyridazine. In a six-membered ring, if the two nitrogens are at 1,3 position, is called pyrimidine. Okay. In a six-membered ring, if the two nitrogens are at 1,4 position, is called pyrazine. Okay. So now let's take one by one, starting with pyridazine, and let's look into the synthesis or the preparation. So first one, it's about how one can prepare the synthesis of pyridazines. So pyridazines means nitrogens are at 1,2 position in a six-membered ring. So here, what you can say that this is 1, 2, 3, 4. So 1,4 dicarbonyl compound. Name of this compound is called 1,4 dicarbonyl compound. So 1,4 dicarbonyl compound, when it is treated with hydrazine. So name of this compound is called hydrazine. What will happen? They undergo condensation reaction. Once there is a condensation, means removal of H2 and O. So what if there is a removal of water, means what will be the formation? The formation will be the C double bond N. So there will be a new bond formation between this carbon and nitrogen, and H2O will go out. So how many? Two water molecule will go out. So these type of reactions are called condensation reaction. So once the condensed, this will be the condensed product. So once the condensed product is obtained, this compound is subjected to oxidation. I think you know that oxidation means is nothing but a removal of electron, removal of hydrogen, addition of oxygen. So in this process, removal of hydrogen. That means you can consider that this is a double bond. This is a allylic hydrogen. Allylic hydrogen. Can be dehydrogenated by using a dehydrating agent, maybe a DDQ, or even you can also, yes, DDQ is the better one. So H2 is removed, and the product obtained one is what is called pyridazine. Okay. So now with this, we'll go to the next slide. So next slide is about the what is called a pericyclic reactions, more particularly 4+2 pi electron system. So this will act as a diene, and this will act as a dienophile. So this bond pair cannot, there will be a new bond formation between this carbon and this carbon. There will be a new bond formation between this carbon and this carbon. There will be a new double bond formation between the two nitrogen. So that is how a cyclic compound is obtained. So this cyclic compound is unstable, and again there will be a concerted 6-electron involvement is there. How means this bond pair is coming over here, this bond pair will go over here, this bond pair will come over here. So that is how the pyridazine is obtained. Here there will be a removal of nitrogen. Nitrogen is a gas, it will go out. Then what is the name of this compound? You can also observe that 1, 2. So 1, 2, 3, 4, 5. So that means 1, 2, 4, 5. Okay, tetrazine. So this is the name of this compound is tetrazines. Okay. So anyway, we will also discuss about the synthesis and reactions of tetrazine later stage. So tetrazines here used as a starting material to get the pyridazines. So these are the two methods. Okay, one method is starting with the dicarbonyl compound. Another method is with the tetrazine, and this is an example of pericyclic reaction. So with this, I will go for a next slide. So next slide, we are discussing about the synthesis of pyrimidines. Okay, pyrimidines means a 6-membered ring with the 2 nitrogens at 1 and 3 position is called pyrimidines. So how this can be synthesized? By taking a 1,3-dicarbonyl compound. This is 1, 2, 3. 1, 3 dicarbonyl compounds when it is treated with amidines. So name of this compound is called amidine. So what will happen? Undergo condensation. So what it means? It means that there will be a new bond formation between this nitrogen and this carbon. What will happen? There will be a new bond formation between this nitrogen and this carbon, and here there will be a OH. Okay, so that means this is OH. And there will be a removal of water, H2 and O, removal of water, and there will be a new bond formation between this carbon and this nitrogen. 2 double bond is obtained. Then afterwards, what will happen? This bonded pair can come over here, OH will go out. That is how a what is called as pyrimidine is obtained. And this is not H2, it is also a H2O. So that's what you can remember. It's a condensation reaction. There will be a removal of 2 molecules of water. So with this, I will go to the next slide. So this is again an example of pericyclic reactions. So this will be a triazine one. Okay, since there is a presence of 3 nitrogens. Okay, so it's in a 6-membered ring, it's a triazine. So what will happen? This will act as a diene. This one will be the dienophile. Okay, dienophile and diene. So there will be a new bond formation between this nitrogen and this carbon. There will be a new bond formation between this carbon and this carbon. There will be a new double bond formation between this nitrogen and this carbon. So that is how this intermediate is called adduct. Okay, 4 plus 2 pi electron cyclo addition adduct is obtained, and this is unstable. So what will happen here? There will be a this bond pair. Okay, so this bond pair can come over here. So then this bond pair will come over here. This will go over here. This will move over there. So here there will be a removal of HCN, and you should aware that HCN is a very dangerous one. Okay, just inhalation leads to the death. Why? Because it will block the what is called as blood. Okay, flow of blood. It will block the blood. So then with this, I will go to the next slide. Oh, okay. Okay, now it will work. So next is about the pyrazine. Okay, pyrazine means two nitrogens at 1 and 1,4 position in a 6-membered ring is called pyrazines. Okay, so how we can prepare? So this is this position is called alpha amino ketones. Okay, so alpha amino ketone, this also a alpha amino ketones. So alpha amino ketone undergoes self condensation, giving rise to a 6-membered ring compound like this. Then afterwards, the obtained one subjected to oxidation, otherwise dehydrogenation, giving rise to pyrazine. So here you can look into that H2 and O, removal of water. Similarly, H2 and O, so removal of water. So you can observe that there will be a new carbon-carbon double bond between this carbon and this nitrogen. Similarly, there will be a new carbon-carbon double bond between the this carbon and this nitrogen. Okay. So then what you will get? So you will get double bond here, double bond here. So then what happens? When this is subjected to oxidizing agent like DDQ, this bond pair is coming over here. This bond pair will come over here. H2 will go out. Removal of H2 and giving rise to pyrazine. Okay, this is one method of preparation of pyrazine. So one more method also is possible just by taking diketone what we can say that alpha, this position is alpha, this is a functional group. Alpha diketones. Alpha diketones when it is treated with 1,2 diamino compounds. 1,2 diamino compounds undergoes condensation reaction, removal of water, H2 and O will go out, H2 and O will go out. There will be a new carbon-carbon double bond between this carbon and nitrogen. This new carbon-carbon double bond between this carbon and nitrogen. So giving rise to this type of compound. So then what will happen? So dehydrogenation. So removal of hydrogen. It is possible with dehydrogenating agent such as DDQ. DDQ is an oxidizing agent. So then the obtained one is pyrazine. So this is about the, so what we discussed about the preparation of pyrazine, preparation of pyrimidine, preparation of pyridazine. Okay. And these are the 3 examples of diazines. Okay. So let's go for a next slide. Okay, now it will come. Okay, so thiazines. So thiazines means here one of the heteroatom is sulfur. Aza means nitrogen, thia means sulfur. What it means? Aza means nitrogen, thia means sulfur. INE means 6-membered ring. So in a 6-membered ring, sulfur and nitrogen containing, if they are 1,2 position, you can write 1,2 thiazine. Okay. If they are in 1,3 position, you can write 1,3 thiazine. If they are in 1,4 position, you can write 1,4 thiazine. But you have to remember that adjacent to the sulfur, there is a saturation. 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 So what another factor also you can remember here. So another factor you can remember here. Okay. Another factor you can remember. Right. All these thiazines are six-membered ring containing two double bonds, not the three double bonds. And adjacent to the sulfur, there is a saturated carbon. That's what you can remember. So now let's take the 1,2-thiazine. So how one can prepare 1,2-thiazine? So this is what you call this particular compound. Okay, here also a strategy called pericyclic. Pericyclic. This is also an example of pericyclic cycloaddition reaction. And this will be the diene, and this will be the dienophile. Okay. So what is the name of this compound? So this is fluoro. Okay. And this is thio. CN. If it is a CN, it's a cyanide. This, yes. Okay. Thiazyl fluoride. Okay. Right. So thiazyl fluoride, name of this compound is called thiazyl. Thia means sulfur, aza means nitrogen, and fluoride. Thiazyl fluoride, when it is reacts with perfluoro means, so there is no hydrogen. All the places fluorine is there. Perfluoro 1,3 butadiene to give 1,2 thiazine derivative. This is the 1,2 thiazine derivatives. How this product is formed? So this bond pair is attacking here. This bond pair is going over here. This bond pair is come to this position. This is for your understanding. I am writing. So as per the pericyclic reaction, you have to mention that there will be a new carbon-carbon single bond between the sulfur and this carbon. New carbon-carbon double bond between this carbon and this carbon. New carbon-carbon bond between the carbon-nitrogen bond between this carbon and this nitrogen. So just by mixing these two, if necessary, on heating, use this product. That is the speciality about the pericyclic reaction. So then with this, we'll go for a next slide. So next slide, one more method of preparation of thiazine, 1,2-thiazine. So here the reactant, okay. So what is the reactant? Reactant is a alpha beta unsaturated ketone. This is alpha beta unsaturated ketone. Alpha beta unsaturated ketone. Otherwise, what is the another name for this? This group is called vinyl group. Okay. Yes. And this one is ether. Ethyl, vinyl, ether. So only this part is called ethyl, vinyl, ether. Okay. Ethyl, vinyl, ether reacts with sulfoxamines. Okay. This is the sulfur, and this will be the oxamine. Okay. Imine group. Okay. This is the sulfur, and this will be the imine. So this complete moiety is called sulfoxamine. So ethyl vinyl ether, when it is react with sulfoxamine, so to give thiazonium oxides. Okay, this is called thiazonium oxide. Why it is oxide? Because oxygen is present. That is the reason it's oxide. Since there is a positive thiazonium. So then how this particular reaction happens? If we are looking at the mechanistic pathway, the lone pair or the bond pair can attack this carbon. It's a attack of nucleophile